Hello everybody. Today in this part we will discuss on a principle of mathematical induction. Dear students, in this part we will solve the following equations, or we need to prove the following equations by using principle of mathematical induction. Now let us we discuss one by one. Using principle of mathematical induction, prove the following: 1 plus 2 plus 4 plus 8 plus 2 raised to n minus 1 is equals to 2 raised to n minus 1 for all n greater than or equals to 1. The students, to prove this statement, we apply the three steps of principle of mathematical induction. Step 1 is we need to prove for n is equals 1. Now let us check for n is equals 1. For n is equals 1, here we have 1. This 1 is equals to, substitute here 1, 2 raised to 1 minus 1. 2 raised to 1 is 2. 2 minus 1 is 1. So 1 is equals to 1, which is true. Step 2. Step 2 is assumption. Assume that it is true for n is equals to k. Means substitute here n by k. That means 1 plus 2 plus 4 plus 8 plus 2 raised to k minus 1 is equals to 2 raised to k minus 1. The next step is we need to prove for it is true for n is equals to k plus 1. We want to show that it is true for n is equals to k plus 1 implies that we need to show for n is equals to k plus 1, 1 plus 2 plus 4 plus 8 plus 2 raised to k minus 1 plus 2 raised to k plus 1 minus 1 is equals to 2 raised to k plus 1 minus 1 is our claim. So our claim is given here: 1 plus 2 plus 4 plus 8 plus 2 raised to k minus 1 plus 2 raised to k plus 1 minus 1, which is 2 raised to k, is equals to 2 raised to k plus 1 minus 1. Dear students, our aim is to obtain such expression. So how we can obtain or how we can prove? To prove this, we need to start from our claim. That means 1 plus 2 plus 4 plus 8 plus 2 raised to k minus 1 plus 2 raised to k. This is the left hand side of our claim. So to show this, what means that this 1 plus 2 plus 4 plus 8 plus 2 raised to k minus 1 from step 2 or from the assumptions, this expression is the same as 2 raised to k minus 1. So here we have 2 raised to k. So we have that 2 raised to k minus 1 plus 2 raised to k. Here we have the same terms here: 2 raised to k, 2 raised to k. 2 raised to k plus 2 raised to k is 2 times 2 raised to k. Here we have minus 1. So by using the properties of exponential function, we have here this 2 times 2 raised to k is to the power of 1 plus k. That means, in other ways, which is the same as to the power of k plus 1 minus 1. This is the required result, which is the same as here. So we said that since it is true for n is equals to k plus 1, and the proof is completed here. Let us we proceed to question number 2. 1 times 2 plus 2 times 3 plus 3 times 4 plus n times n plus 1 is equals to n times n plus 1 times n plus 2 the whole over 3 for n is greater than or equals to 1. Students, to prove these expressions using principle of mathematical inductions, we use the following three steps. The first step is we need to check whether the given expression is true for n is equals to 1. That means for n is equals to 1, here we have 1 times 2. As equals to substitute here n by 1, we have 1 into 1 plus 1 times 1 plus 3 the whole over 3. So here 1 times 2 is 2, and this expression is 1 times 1 plus 1 is which is 2. 1 plus 2 is 3, and this 3 is cancelled by here 3. We left what? 1 times 2, which is 2. So 2 is equals to, which is true. Next step is assumptions. Assume that it is true for n is equals to k. Means that substitute k, n by k, and we have 1 times 2 plus 2 times 3 plus 3 times 4 plus k times k plus 1 is equals to k times k plus 1 times k plus 2 the whole over 3. This is the assumption part. Next, step 3. Step 3 is we need to show that this expression is true for n is equals to k plus 1. It implies that we can add the same properties of the given expressions and add k plus 1 in both sides. It means that our claim is we make that 1 times 2 plus 2 times 3 plus 3 times 4 plus k times k plus 1 plus k plus 1 times here k plus 1 plus 1 is equals to, by substituting here n is equals to k here by k plus 1, we have k plus 1 plus here k plus 1 plus 1 and here k plus 1 plus 2 the whole over 3. Or shortly, step 3 is we want to show that it is true for n is equals to k plus 1. Means that our claim is given here 1 times 2 plus 2 times 3 plus 3 times 4 plus k times k plus 1 plus k plus 1 times k plus 2 is equals to k plus 1 times k plus 2 times k plus 3 the whole over 3. Here is our claim. Dear students, to prove the given expressions, let us start from the left hand side of our claim. The left hand side of our claim is here, so that we have 1 times 2 times 2 times 3 plus 3 times 4 plus k times k plus 1 plus k times k plus 1 times k plus 2. This is our left hand side of our claim. But from this expression, this or up to this is from step 2, means that 1 times 2 plus 2 times 3 plus 3 times 4 plus k times k plus 1. From step 2 is the same as with these expressions, k times k plus 1 times k plus 2 the whole over 3. And we left what here? Plus k plus 1 times k plus 2. Now, by taking the LCM here, we have k into k plus 1 times k plus 2 plus here 3 into k plus 1 times k plus 2 the whole over 3. Dear students, here we have a common k plus 1, k plus 2. By taking the common k plus 1 times k plus 2, we have what? K plus 1 so times k plus 2 so into what? K plus 3 the whole over 3. This is what the required result. And we said that hence it is true for n is equals to k plus 1. Dear students, today enough. Next time, so in the next part, we will discuss the other questions like 1 plus 4n less than or equals to 5 raised to n for n greater than or equals to 1 and the other questions. And thanks for watching this important video. And if you have any comments, you may write in the comments. And thanks.